Right, hello everyone and welcome to my LinkedIn channel, okay? And first one, I'm gonna take a look at my profile. This is my profile. You can see all my project in here. Well, it's contain many website development, but the most of them are related in data science and something kind of machine learning or deep learning. And you can also see my activities here. I have posted many insights about the algorithms, encryption algorithms, and many of them, okay? And you can also see my project. Inside here I got many licenses, and yeah, today I'm gonna want to show you my project I'm doing it during my study time in my university. This is a AI a model to scan through the SSH log status and then gonna predict it, does it illegal or illegal, and what is illegal or illegal. As you can see, this is the data. It has 7 columns: the ID, the date, the status, the users, the IP, host, and is illegal. Yeah. Okay, and our mission is, how can I predict the is illegal column when I just need to reading all of these data, okay? And the things that I label it as the is illegal, if the data containing something like invalid or authentication fail or something kind of like that, here it failed, and I'm gonna give it the is illegal equal 1, so and the other is just a 0, okay? Now I'm gonna show you my model here. I train 3 models. 2 of them are neural network and 1 of them are random forest regression. And this is my first one. All of the other library and packages that I'm using. The first one, I'm gonna read my data here, okay? And then the shape of the data is contains 7 columns and more than 1 million rows, and I want to change my days into the daytime. Well, when you just use this, it cannot be let your model study this, okay? Then just change it into the daytime, right? This is the daytime. And then I'm gonna drop on the NaN columns and drop on the duplicate data inside my data set. Okay. Now it just only have the 1,048,575 rows and 7 columns. Okay. This is the infos of my data frame. You can see the day is now daytime. Then I'm gonna split my date into the 6 different columns called years, month, day, hour, minutes, and second. So in order to make it more easier to contact, and the reason why I do this, okay, just make it more diversify my data. Now I got on this column. I drop the day because I don't need it anymore. I already split it into 6 more new columns, so I'm gonna drop the date. Then I'm create my new label encoder in order to encode the user, the IP, the host, and the status, and to make the model can learning it. Okay, I store my label inside here, and then I'm gonna split it. The X I will use all the other columns, but except this column, the ID, well, don't mention it. It's not really important. It's here. The status, the user, IP, and host. These 4 columns are already encoded, so I just use the encode column. Okay, this is the column that I need to predict, so I use this and then I split the data. I use 80% for training and the other 20% for testing. It means the validations here. Then I'm gonna scale my data. Okay, I scale my data into 3 parts. X train, X validation, and X test. This data generator mean when each repo training, I'm gonna solve for my data once in order to make it more diversity for my model to learn many different situations, okay, and also the validation. Now this is my model. My model is a sequence model. It has 3 layers. The first layer contains 128 neurons, and the second is 64, and second is 32, and you now can see it. Yeah, the numbers of neurons inside these hidden layers are decreasing. And the final one, I just need a 0 or 1, so make it prediction like, is it illegal or not illegal? Well, just 0 or 1, so I'm using the sigmoid activation. Okay, the learning rate I gave it is 0.005, and using the ADAM algorithm with this learning rate, and then I'm gonna compile with it here, the early stopping. If there's just 3, no enhance, nothing in my model, I'm gonna stop the training program and reduce the learning rate to find the most fit learning rate. The training generator, using the data generator, say solve for the data, the validations, and train my model. Using that train generator with epoch is 100, and validation is a validation generator. The callback is early stopping and reduce RL, okay, learning rate. This is the learning. You can see the accuracy increasing time by time. Also the accuracy one here also increasing. The loss is decreasing time by time, which is really good. And you see the validation accuracy also increase. The validation here also increase, and the validation is also decreasing. Yeah, okay, you can see here. And then the test. After train my model, I'm gonna generate my test using the validation generator inside, and I'm gonna use it to test. I got the accuracy is nearly 84.76%, and the loss is this, which we kinda accepted. And then I'm gonna using just take the 0.1 column is illegal. Now I got the validation accuracy here, and this is the map plot lib I used to see. Okay. Here, right. This is the confusion matrix and the accuracies. Now let me take a look. My second model is kind of like the first model, but I add more things like the batch normalization and the dropout. I decrease the dropout from 0.5 to 0.3 in order to make it learning more neural inside the hidden layer. Okay, also the same, and I decrease the learning rate from 0.5 to 0.1, and right now I'm not using the reduced learning rate to find the batch pattern anymore. And the label encoder, in the upper, I already use it, so I just load it inside my folder that I stored in. Anyway, here you go, I store here and just load it, then generator and fit. You can see the accuracy increasing time by time, the loss also decreasing. Yeah, it's good, right? Using the prediction, yeah, 84.8, 57%. Okay, this is the learning, which is good. Now this is the test. This is the confusion matrix. Wow, it's highly accuracy. Now this is the confusion matrix, okay? And my third model, I'm using the random forest with the n estimator is 100, mean sleep is 1, and the max depth is 20. So I use train this with my strength scale, and so do that on the upper, and this is the mean absolute and mean square error, which is good. Store my model. Well, you cannot really care about this, but yeah, right, don't care about it. Here you go. You can see I'm using the stack layer, the stack model. Okay. Alright, this is the real time, or not real time, just a real test on the new things. Now I'm using my first model as a testing here, using the same data frame, and so like that, and I can use it to predict, scale them, use a model to predict, flatten. Well, do not care about this, do not care about this, and here. Okay, I'm going to create a new columns. Column predicted is illegal, and use my predicted press here. It's equal this, and then draw this in my confusion matrix. While the accuracy is here just nearly 60%. Wow, it's not really accepted, but I'm gonna increase them in the futures. Alright, and this is my process. Well, I'm gonna scan each user stated. If in the 3 minutes they are predict that is illegal more than 5 times, I'm gonna add them into the alert user CSV, which means this user is illegal. They are not allowed here in my system. So I'm gonna add them into the alert user, and in futures I'm gonna deploy my model on something kind of like a Linux operating system to scan the data logs in real time, and when any user has any illegal interactions on my data, on my log, on my SSH service, anything, I'm gonna ban them, or I'm gonna stop them from doing that things. Okay, and after I run this, you can see right. Well, it's kinda not here now. Okay, after I run this, it's gonna save my alert user here. You can see these are all the user that is illegal during the time I making this. You see Aaron, adult admin, administrator, client deploy, and many more users. These users are illegal. So that's all. This is my project about predicting the SSH log and the illegal user that they interact with your SSH in order to control the connection flow in your SSH log. Okay, see you next time.